Have you ever wanted to precisely record neurophysiological signals with an adaptable, powerful, closed-loop system? Look no further than using the Cortec Brain Interchange device with BCI2000. The Brain Interchange is a fully implantable system designed for long-term measurement, which can both record and stimulate the nervous system using custom-made electrodes. This cutting-edge technology is undergoing clinical trials with the eventual application of treating Parkinson's, epilepsy, and other disorders in humans. BCI2000 has transformed from a simple brain-computer interface program to a versatile behemoth, thanks to over 20 years of development and community contributions to the open-source platform. It integrates both clinical and research systems into a standardized infrastructure to run experiments and efficiently analyze data. It supports real-time signal processing, which can be used to conduct brain-computer interface tasks or closed-loop stimulation. The integration of the Cortec Brain Interchange in BCI2000 is especially useful because it introduces capabilities of the Brain Interchange that were otherwise unavailable with their default interface. The Brain Interchange comes with a default user interface that allows you to record and stimulate out of the box. It provides a visualization of the signal, as well as an impedance measurement. You can also stimulate channels with custom waveforms, allowing for multiple functions and repetitions. BCI2000 not only includes all these capabilities and improves on them, but it also introduces completely new possibilities. First, let's review how it replicates those default abilities. The acquired signal is viewed in BCI2000, and you can add filters for visualization purposes, which don't affect the raw signal that is being saved. As for the data acquisition parameters, you can specify the reference channels, amplification factor, and whether or not to use the ground electrode while measuring. As for the stimulation parameters, they are available under the Stimulation tab in BCI2000's configuration window. Just like the default application, you can set the individual parameters, such as channel, pulse width, amplitude, dead zones, and repetition. Not to mention the ability of measuring the impedance, which is automatically saved to a text file. Now that the default configurations are covered, we can go into the additional features. As you may have noticed, there are a couple more stimulation parameters, specifically train frequency and train repetition. This allows for trains of stimulation bursts, which can be set at any frequency. The stimulation commands themselves can have varying modes, created by Cortec, and this interface allows you to choose them. They affect the latency of the stimulation, with less latency made possible by limitations. The volatile mode is the most flexible mode, with the highest latency. The persistent modes have a lower latency, but the persistent function mode doesn't allow any stimulation trains, while the persistent command mode only allows one stimulation configuration. The setup of the stimulation parameters can get overwhelming, so we have provided a standardized tool to help create stimulation configurations, called SCIT. This MATLAB program provides a visualization of the stimulation waveforms as you create them, guaranteeing the validity of the parameters, and it visualizes at 3 timescales: waveform, burst, and complete simulation train. Once you have the configurations completed, you can simply export them to a parameter file that can directly be imported in BCI2000. These stimulation configurations can additionally be started with any BCI2000 expression, which can harness a multitude of BCI2000 settings. This includes experiment conditions, such as visual or audio stimuli, process brain signals, such as the power of a spectral band, or by another device's behavior, such as a motion tracking sensor exceeding some threshold. This adaptability allows for closed-loop control with any experimental condition. Now that we have established why using the Brain Interchange with BCI2000 is desired, we will discuss the necessary steps and how to set up the system. First, you will need a BCI2000 system on your computer. Follow instructions on the Wikipedia page for how to install a local BCI2000 version. You will need access to the private directory to interface with the Brain Interchange, as it is not released for the public yet. You'll also need to download the Cortec drivers, which are contained on a USB drive that comes with the device. While you are setting up BCI2000, you can also connect the Brain Interchange. In this video, I have been showing the evaluation kit, in which the implant is contained in this box. This can be useful to conduct any testing without needing to implant the device. To set up the system, simply connect the available cables and connect the USB to your computer. Once the ready light is green, we are good to go. Once BCI2000 is configured and built, run a BCI2000 instance with Cortec ADC as your signal source module. Press set config, and it should connect to the Brain Interchange out of the box. It can occasionally take a while to make the connection, but the feedback of the lights on the interchange, as well as the command log, lets you know it's still in the connection process. Now that everything is set up, we can take advantage of the system's capabilities we have previously mentioned. Before we show the demos, let's address troubleshooting the wireless connection. If the headpiece disconnects from the implant, the data is immediately lost. BCI2000 is set up to continue running in this case, and all you have to do is reapply the headpiece to the implant and press set config again to reset the data acquisition process. Secondly, since the data connection is wireless, data may be lost. In the initial versions of the Brain Interchange, the headpiece provides the power to the implant, however the communication unit receives the data. This means that the distance and orientation of the parts affect the quality of the data transfer. Hopefully the data communication protocol will be improved as further versions are deployed, but for now this is an issue to be aware of. Thanks for watching our video. Explore our wiki page for other tutorials and uses of BCI2000.